There, and thanks so much for joining me for this video. So right now I'm going to talk about how to conduct a dependent or paired sample t-test in SPSS. So really quick, let's talk about the similarities between the last test that I talked about in my last video and the paired sample or dependent t-test, right? So both independent sample and dependent samples t-tests are used whenever you have one categorical variable with two levels and one continuous variable. And typically, your one categorical variable with two levels is going to represent your independent variable or be represented by your independent variable, whereas your continuous variable is going to be your dependent variable, right? So I think the last example I gave was if you looked at whether males and females have different spatial memory scores, right? So if you were to devise some kind of test measuring spatial memory, maybe you would hypothesize that males have higher spatial memory scores than females, right? So again, for both independent and dependent, we've got one categorical variable with two levels, which is typically the variable that the investigator or researcher manipulates, and one continuous variable, right? Which is typically the outcome variable or dependent variable. But the critical difference between independent and dependent samples t-tests are that with independent samples t-tests, you're comparing statistically two different groups of people on the same measure, right? So males and females, and then you would compare both those different groups of people on the same measure, which is spatial memory. But with dependent samples, rather than comparing two different groups of people, you are comparing the same group of people at different points in time, right? So these are typically conducted whenever you're doing longitudinal research. So for example, maybe you're looking at spatial memory in infants before and after they start crawling, right? Because you hypothesize that your depth perception and all of that doesn't kick in until you have a certain gross motor function, right? And you're able to explore more of the world, right? So you hypothesize that compared to infants who haven't started crawling, infants who do crawl are going to have more spatial memory than infants that haven't started crawling. So that's a situation, a longitudinal developmental psychology study. Another situation where you might do a dependent samples t-test is if you're looking at some kind of intervention, some sort of medical intervention or intervention for maybe a psychological disorder. So maybe you're looking at depression score or PTSD score after taking a certain medication or after having some kind of therapy. So maybe cognitive behavioral therapy or eye movement desensitization therapy. That's a hard word to say. Things like that. So again, you're looking for change within the same individuals, right? So that's why we call independent samples t-tests between subjects tests, and we call dependent samples tests within subjects tests, right? Because you're looking for change between two different groups of people with independent t-tests, and you're looking for change within the same individuals when you're conducting a dependent samples or paired samples t-tests, okay? All right, so let me go ahead and share my screen so we can get to the nitty-gritty SPSS stuff. Okay, so the data set that we're going to work with today is the SAT course data set. And essentially this data set is comparing SAT scores in these participants before and after they participated in a 6-week SAT prep course, right? So essentially what we are trying to determine when we conduct our t-test, our dependent samples or paired t-test here, is we're trying to determine whether their SAT scores improved after taking this course or not. Okay? So there are two ways that we can sort of get at this information. One way is to look at our descriptive statistics, right? And whenever we have a continuous dependent variable that we're analyzing, we can look at the mean and standard deviation. Okay, so we can look at the mean SAT score prior to the course and see if that's lower than the mean SAT score after the SAT prep course. So that'll give us some sense of whether there's an improvement. But in order to see if that difference is significant or not, or in order to determine whether we can reject the null hypothesis that the SAT prep course has an effect, right? Or that we can reject the null hypothesis that the SAT score before the SAT prep course is equal to the SAT prep. In order to reject the null hypothesis that the SAT score before the SAT prep course is equal to the SAT test score after the SAT prep course, then we have to conduct a paired sample t-test, right? So we might deduce from looking at the means, right, that the SAT score of these participants did in fact increase after the prep course. But in order to determine whether that difference is significant, we need to conduct a paired sample t-test. Okay, so how do we do that? Well, first, what we're going to want to do is make sure we have all the right variables. Okay, so if we look at variable view, so if we look at variable view, we have SAT pre, which is the SAT score before the SAT prep course, and SAT post, which is the SAT score after the course. Okay, so we know that we have all the right variables there. So in order to conduct our paired sample t-test, we're going to go to compare means. So analyze, compare means, and paired sample t-test. Okay? And what we're going to do is for a lot of reasons, it's actually easier if you select your after variable and put that as variable 1, and then your before variable as variable 2. Okay, so that's what we're going to do. And again, all that you're doing is taking your variables from this box and moving them over to variable 1 and variable 2 here. Okay, so these are the two variables that we're comparing, or the two levels that we're comparing. Okay, so we're just going to go ahead and click OK. Okay, and that gives us our output. Okay, so first, what do we have here? Well, under paired sample statistics, we've got our means. So this is the mean SAT score after the prep course, and this is the mean SAT score after, or before. Okay, so after and before. Okay, So after the SAT prep course, the average SAT score is 1094 as compared to the average SAT score before the prep course, which is the 1074. Okay, so right there we see that that's a 20% difference, right? So that seems like a fairly big difference. But in order to determine whether we can reject the null hypothesis that these scores are equal to each other, we need to look at our t statistic, right? And just so you know, we also have n here, which represents the sample size. And again, the sample size is going to be the same because we're comparing the same group of people, right? Whereas sometimes the sample size is different if we have two groups of people that we're comparing. And then we have the standard deviation, okay, for each of our measures that we're comparing before and after, and the standard error, okay? Okay, so let's look at our statistic, right? So we're going to go to paired samples test, and that's going to give us the mean of our difference score, just like we would calculate by hand, the standard deviation of our difference score, okay, our t-value, our degrees of freedom, and our significance value, or our p-value. Okay, so if we look at that, our t-value is 1.686. Our degrees of freedom is 159, okay, which is again just n minus 1. And our significance level is 0.09, okay? So how do we know if this is a significant difference or not? Well, we're going to apply the same decision rule that we always do, okay? And that's that if our significance value is less than 0.05, then we reject the null hypothesis that these means are equal, okay? But it looks like our significance value is 0.09, which is bigger than 0.05, okay? So we have to retain the null hypothesis, okay? So what this means in effect is that even though there is a mean difference here, okay, we do not have evidence that there's a significant difference between these two means. Okay, so therefore we retain the null hypothesis and conclude that there is not a significant difference between the mean SAT score before the prep course and the mean SAT score after the prep course, right? And this obviously has real life implications, right? Because it suggests that it may not be worth the money for an SAT prep course, right? If the difference that is observed or the potential benefit that's observed after in your SAT scores before and after the prep course, if that's not significant, then that suggests that maybe it's not a worthwhile investment. If we don't have statistical evidence that the improvement that you might incur as a result of the prep course is actually a significant difference, then it suggests that the potential advantage that you might incur after taking the prep course isn't really that significant, right? Okay. So this concludes my tutorial on paired sample t-test, and I look forward to seeing you guys in lab on Thursday, and feel free to contact me if you have any questions. All right, I'll talk to you guys later.